Hello students, welcome to classroom teaching. I am Shekhar. Students, you might remember in last video we have seen about gravitational potential energy, and we derived the formula for that also. Gravitational potential energy, it is equal to Gmm upon R, or you may say R plus H. And from that formula we derive that this potential energy, it becomes zero at certain height, and that height we call it as infinite distance. At infinite distance it becomes zero. Students, today we are going to discuss about a similar article which depends on this fact only, and that is nothing but escape velocity. Friends, if we throw any ball in upward direction, then it reaches to certain height and definitely it starts falling down. If we throw the same ball, I have a ball here. If we throw the same ball with greater speed, then it may reach. If we are throwing a ball from here, if we throw a ball in upward direction, it goes to certain height and then fall down. That means as the gravitational pull, it reduces, that we see in last video. Similarly, the velocity also goes on decreasing. That means if we throw a ball in upward direction, its velocity goes on decreasing. At certain height, the velocity, it becomes zero, and after that it starts falling down. And of course, it is due to the gravitational pull, that we know. But if we throw the same ball with greater speed, what will happen? It goes to somewhat large distance. It covers somewhat large distance. That means go to the height, more height, and after that it starts falling. Here the velocity becomes zero, and after that it starts falling down. What happens if we throw it with greater and greater speed? Definitely the ball, it can cover larger distance. That means it can go to higher heights, more height. But definitely after that the velocity becomes zero and it falls down. Students, in science, or particularly in physics, everything we have to prove. That means we are saying if we throw it with greater speed, what do you mean by the greater speed? It is nothing but the initial velocity. That means the height which is to be reached, or the ball which has to cover the distance, that depends on the initial velocity, and that we can prove by using Newton's equation of motion. We know the three equations of motion. What is the third equation of motion? In last period, I told you that each time you have to keep a notebook with you and a pen. So write the equation of motion in your notebook. I will write it here. V square is equal to U square plus 2AS. So it is nothing but final velocity. Final velocity, definitely whenever it reaches the height, particular height, after that the final velocity, it becomes zero, and therefore we take V is equal to 0 here. And as the acceleration, it is due to gravity only, because we are throwing the ball in upward direction, then definitely A is equal to minus G. Why the minus sign is there? Because the velocity of the ball is in upward direction, and the pull of the earth, that means acceleration, it is towards the downward direction. So put these values here. So we get 0 is equal to u square minus 2gs. So we have to calculate the value of s here. So take it in this side. U square, what is u square is equal to? U square is equal to 2gs. So what is s? What is the value of s here? S, it is nothing but u square upon 2g. Here, for smaller distances, the value of g is constant, that is 9.8. So, the distance covered by the ball, it is nothing but the distance covered by the ball, and we are throwing the ball in upward direction. That means it is nothing but height. So, height to which the ball reaches, that depends on u square, that means on square of the initial velocity. So, if we go on increasing the initial velocity, definitely ball it reaches to more and more height. If I throw the ball from here, if I throw the ball from here, it reaches certain height, definitely falls down. But I go on increasing the velocity, initial velocity, and as we go up, as we go to greater heights, we know the gravitational acceleration also goes on decreasing, and due to that, it is easy for the ball to reach the higher heights or to go in higher and higher direction. Why? Because it is easy for the ball to overcome the gravitational pull, because the value of gravitational pull, that is nothing but gravitational acceleration, it goes on decreasing as we go in upward direction. And due to that, what happened? One time comes whenever if I throw the ball up to infinite distance. So suppose this is infinite distance. Actually, this diagram, it is not in proportion. It is not in proportion. If I throw the ball in upward direction and if it covers infinite distance, then what happens? Definitely we know at infinity value of g is equal to 0. And if the value of g becomes 0, that means there is no downward pull by the earth, because there is no gravitational force there. The ball overcomes the gravitational force and it reaches to the infinite distance. Then the ball, it never falls down on the earth. It remains in the space only. It never falls down. And this velocity, which velocity? This initial velocity with which we throw the ball, that initial velocity is called as escape velocity. That initial velocity is called as escape velocity because the ball can escape the Earth's gravitational force, and that initial velocity, after that the ball never falls down on the Earth. That initial velocity is called as escape velocity. Think, if I throw the ball with more speed, that means if I use more initial velocity, the ball covers more distance, and after that the velocity becomes 0. Definitely the v, it becomes 0 after covering certain distance. So here definitely this ball also never fall on the earth. But this is not called as escape velocity. This initial velocity is not called as escape velocity. Why? Because the escape velocity, it is the minimum velocity, minimum initial velocity which is used or which is required to overcome the gravitational force. That means to overcome the gravitational force of attraction, gravitational pull. So the velocity of the ball must become 0 at infinity, and therefore it remains here. What happened in second case? The velocity is more than that escape velocity, then it goes in further direction. It goes after that also, after infinity also it is going forward. The velocity never becomes zero here, doesn't become zero, and therefore the escape velocity, it is nothing but whenever the object or the ball, the velocity of the object, it becomes zero at infinity and it remains there. That means suppose this is the gravitational field of the earth. So just above the gravitational field of the earth, the ball, velocity of the ball, it becomes zero here. That initial velocity, it is nothing but escape velocity. And definitely we can find out the value of that escape velocity. Friends, let us calculate the value of that escape velocity. One thing, now we know that escape velocity, it is nothing but the initial velocity. So, to find out this value of initial velocity, this escape velocity, we use the law of conservation of energy. What is the principle of conservation of energy? We learned it in 8th standard or 9th standard. What is it? The total energy gets conserved. That means energy cannot be created nor be destroyed. Only we can convert one form of energy into another form. So that is nothing but law of conservation of energy. That means the entire energy, the total energy remains constant. So let us calculate the energy on the surface of earth and energy, total energy at infinite distance. By the law of conservation of energy, these two energies must be constant because we know the total energy gets conserved. The total energy which is present on the surface of earth, that is nothing but converting into the energy at infinite distance. So they must be constant. And what is meant by total energy? We know total energy is always equal to potential energy plus kinetic energy. So let us calculate potential energy and kinetic energy. Then we can get total energy. Okay, what is kinetic energy? Kinetic energy is equal to the formula that we know, half mv square. And what is potential energy? Again, the formula that we know. In last video we learned about that. What is it? G m upon r. This is potential energy. Now tell me what is, and it is minus. You know the meaning of this minus sign that we learned in last video, that is gravitational potential energy. We know the gravitational potential energy becomes zero at infinite distance and potential energy at any point less than that of infinite distance, that is nothing but minus, because it goes on increasing with height and at infinite distance it becomes zero. So at any distance less than infinity it is always negative, that we learned. So potential energy is this much. So what is total energy? So total energy is equal to kinetic energy plus potential energy. So half mv square, this is minus g m upon r. So the total energy that we calculate here. Now at infinity, calculate the total energy at infinite distance. What is kinetic energy? The formula is same, half mv square. But the final velocity v is 0 at infinity because ball is going to, or ball is coming to rest at that infinity. The velocity, it becomes 0 there, and therefore the kinetic energy, it becomes 0 there. What should be the value of potential energy there? Potential energy it is also zero at infinite distance. We know if there is no gravitational force, there is no gravitational acceleration, and therefore the potential energy, it must be zero there. So potential energy is also zero at infinity. So what should be the total energy? Total energy must be zero. So total energy on the surface of Earth and total energy at infinite distance. And by the law of conservation of conservation of energy, by the principle of conservation of energy, we know that the total energy must conserve. That means this total energy must be equal to this. So take these two energies as equal. I will write it here. Half mv square minus gmm upon r is equal to 0. So the total energy is, it must equal to 0. So solve it. Half mv square is equal to gmm upon r, where capital M is always the mass of Earth, small m is the mass of object, and r, it is nothing but the distance of the object. Because as we are taking initial, this r, it is nothing but the, initially we are taking r, that means initial velocity, it starts with ground only, and therefore r is nothing but the radius of Earth. So if we calculate, we get v square is equal to 2gm upon r. So what should be the value of v there? V must be equal to under root 2gm upon r. So actually we know the value of capital G, we know the value of capital M, we know the value of capital R also. So we can calculate this velocity, and this velocity is escape velocity we are calculating, and therefore we write here ESC, escape. So V escape is equal to under root 2gm upon R. Okay, so V escape is equal to under root 2gm upon capital R. If we multiply and divide by capital R here, then what we get? V escape is equal to under root 2gmr upon r square. So gm upon r square, it is nothing but the value of small g. So V escape is equal to under root 2 into small g into r, 2gr. So this small g is nothing but gravitational acceleration. We know the formula for that, gm upon r square. So just put the values of g and r. So V escape is equal to under root 2 into 9.8. It is the average value of gravitational acceleration on the surface of Earth into capital R. What is capital R? 6.4 into 10 raised to 6. If we calculate, then we get, it is nothing but 11.2 kilometer per second. So V escape is equal to 11.2 kilometer per second. This much high initial velocity if we have, then definitely the ball, it can escape the gravitational force of Earth. That means gravitational field of Earth, and therefore it never come back on the Earth. We are talking ball, but any object. The spacecraft that we launch, this spacecraft which is going on moon or other planet, we have to keep the initial velocity which is more than this. Because if we keep the velocity more than this, then that never come back or never fall on the surface of Earth or never get attracted towards the Earth. Why? Because it can escape the gravitational force of Earth. So this is nothing but escape velocity. And with this article or with this small article, escape velocity, we complete this chapter. This is our last article of the chapter. So we will stop here, and from next video we will start next chapter, and after this I am going to start light, refraction of light. Thank you.